started to start at 7 last time? Did you guys start at 7?
Yes.
Okay, what are we working on assignment 7?
I think we got up to problem.
We're talking about factoring?
Yeah.
Solving by factoring? Did you guys kind of review factoring a little, or think about factoring, or practice factoring maybe? Okay. Let's look at a problem that asks us to solve by factoring. Now, which one did we do last time?
I think we did number 4.
We did number 4?
Mhm.
Let's try number 5. Number 5 is a little bit funny. Okay. So what is funny about number 5? Number 5 says 4x squared plus 33x equals negative 54. What is weird about that?
The way it's set up.
The way it's set up. Okay, so what do I need to do with this before I can do anything with the quadratic equation?
Make it equal to 0.
You always have to have it equal to 0. Okay? So before you can do anything with the quadratic equation, you've always got to get everything on one side. So I'm going to add this 54 to both sides. Get that to be plus 54 on the left side. And then I can start trying to factor. Okay? Another thing I might want to look for is if I can take out any common, like greatest common factors. But it looks like that 33 is kind of messing that up, so I can't take out a 2 or a 4 or anything. Okay, so do we want to use the AC method? Is that okay? Okay? So let's try the AC method. And if you guys just want to guess and check, again, that's totally fine. Some people like to have a method just because it's, a procedure you can follow. Okay? So in this problem, my A is 4 and my C is 54, so I'm going to multiply those. Okay, and what is that? 216? Then I'm going to think about numbers that multiply to 216 and add up to 33. Okay? Now this seems like kind of a random combination here. Multiply to 216 and add up to 33. I would just start dividing 216 by 6. Just divide it by 3, divide it by 4, divide it by 5. I can make be divisible by 5. Divide by 6, 7, 8. Just start dividing stuff until we find some combos that multiply to 216. Okay, well I found 12 and 18. That doesn't add up to 33 though. You said 9 and 24? 9 and 24. So 9 times 24 is 216. And 9 plus 24 is 33. So that is going to work. Okay, now what do I want to do with 9 and 24? Okay. Well, I see people do that a lot. Don't write this down. I see that a lot. I see x plus 9, x plus 24. Does that work here?
No.
No, that doesn't even work. But for some reason, people kind of have a brain fart. Lots of times on tests, and I see that a lot. Okay, what do I do with 9 and 24?
How did you get the 24 again?
They multiplied equal.
Right, I want to split 33x. I want to split 33x into 9x and 24x. That's what I want to do with it. Okay? Then I'm going to group factor. I'm going to factor the first two terms, and I'm going to factor the second two terms. So what can I can I take out of 24x and 54? Okay, you can take out a 2 or 3, or the highest would be 6. You want to take out the highest possible thing. That would also leave me with 4x plus 9. And if you notice that my parentheses are the same, which is good because we have to have that to move forward, because I'm going to take out this parentheses. Okay, so what would my final factorization be? 4x plus 9. And the other one is what is left in front here, which is x plus 6. Okay, now my last step is to set those factors equal to 0. Okay, so 4x plus 9, in order to solve for x, I need to subtract 9 and then divide by 4. You guys can do those in your head, that's okay. I get negative 9 over 4. Okay, and then to get x plus 6 equals 0, I need x equals negative 6. Okay, so my two answers here are negative 9 over 4 and negative 6. Okay, you just want to write those with a comma in between them. Alright, now were there any other factoring problems that were funny? Just number 5. This is graphing. Graphing. You guys remember how to graph to find the x-intercepts of the zeros? Okay, graphing. Those are pretty easy. Graphing. Okay, and then we run into the root method after we get through those graphing problems. So let's talk about the square root method here. Okay, and remember that was our second method. Our first method was factoring. Second method was square root method. And just the root method. And our third one is the quadratic formula. Okay? And then for any of those, you kind of have an alternate of trying to use the graphing calculator. Okay, that was just a review from last time, so you guys should already have that in your notes.
Okay, I've got a question. Now, what you're saying is that, like the square root method obviously isn't always going to work.
Right.
Will any of them always work?
The quadratic formula is the only one that always
Okay, and
works.
I think that's the one that I learned, and I think
Factoring
that's why
does not
aren't.
factoring does not always work.
Okay.
The quadratic formula always works.
Okay.
The square root method, you only want to use this when the directions say to. It is not something you can do on every problem. I see sometimes people try to do this in places where it's not really applicable. What you want to do is you want to try to get x squared by itself, or get your stuff that's squared, get that by itself. Okay? And then what you want to do to get rid of x squared is you want to square root both sides. take the square root of a number that wasn't already there.
You need for it to be a, like, it needs to have a square root.
It needs to have a square root. It could be positive or negative. Okay? Because if I'm going to square something and get an answer, then I could square the positive of it, or I could square the negative of it. Okay? And remember, those quadratic functions have two answers. They cross the x-axis twice. So to get your two answers, you need the plus or minus square root for your answers. Okay? You don't need to write the plus in front of the positive one, just the negative one. Alright? So if you've got x squared equal a number, okay, well, square root of a squared would be x. The negative square root, when you square it, would also be the positive answer. Okay? So just kind of the general rule of thumb is if you take the square root of a number and it wasn't already there, you need to have a plus or minus in front of it. Okay, plus and minus in front of it. Okay, so let's look at number 11. Number 11 wants me to solve 4x squared minus 49 equals 0. Now there's actually another way you could approach this problem. Anybody see that?
Square root.
Well, it tells me to use the square root method. What's another way I could do this?
You could divide both by 4, I think. No, you can't.
Not 49, no.
Not 49.
Can you guys factor this? This is the difference of squares. So this actually does factor. Okay, let's put this all off to the side. Alternate here. Okay, this actually is the difference of squares.
2x plus 7, 2x minus 7.
So we factor to 2x plus 7, 2x minus 7. Okay, if you've got two things that are perfect squares, then you can factor them into the same thing with just a plus or minus difference.
Oh, sorry about that.
Okay, now let's go back to the square root method over here. For the square root method, what I want to do is I want to get my x squared by itself. Okay, so what do I need to do to get that x squared by itself? I need to add 49 to both sides.
And then you divide by 4.
Then I want to divide by 4.
Then we square. Then we square root.
Alright, hold on here. Let me get my screen to cooperate here. Okay, so I've got x squared equals 49 over 4. Okay, then I want to do the square root of both sides. So square root of x squared. Okay, and then I need plus or minus square root of 49 over 4.
Plus or minus is important.
Plus or minus is very important, yes. If you forget the plus minus, you only get
Can you scoot it up just for a minute?
half unit. Sure. Now, how do I take the square root of a fraction?
Okay.
You just take the square root of the top and the bottom. And since these are both perfect squares, square root of 49 is 7, square root of 4 is 2. So I'm going to get 7 over 2 and negative 7 over 2. So you can kind of think of this as square root of 49 over the square root of 4. Okay, because that square root would apply to the numerator and the denominator. Don't think you'll see that here. You just have to deal with them separately.
Actually,
You got one that's not a perfect square?
Problem 14, which is kind of far out there, it does end up with a, mine ends up with -3 minus square root of 13 over 2, which is, so it just doesn't go any farther, because those are all prime.
Okay, this problem should all have perfect squares in it. Okay, now if I go back and I look at what I factored, if I set those factors equal to 0, what would my answers be?
Same thing.
The same thing. Now, which way is easier here? Probably the factoring. Okay? But if it's something that is not the difference of squares, then you're going to have to use the root method on a problem like this.
What about, can you use the quadratic on this
You
one?
can always use the quadratic formula. That works on every problem. Now, the quadratic formula uses a, b, and c. Now, so my a here would be 4. My b is not there. So what would I put in for b?
0.
0. Okay, b is not there, so you just put in 0 for it. My c would be -49. Okay, so yeah, you can totally do that.
She's done it right now.
Okay, you guys want to try 12 on your own for a second? Or 13 if you're on 13? Let's look at 12 and 13 for a second on your own.
Now, in that problem, how do you know that it's b that you're missing? Because there's
Because
no x?
it's ax squared bx is b. There's no x, and b